Now let's solve a problem related to these topics. So first one, a body is projected with a velocity of 200 meter per second at an angle of 30 degree above the horizontal. Now calculate the time taken to reach the maximum height and B its velocity after 16 seconds. Okay. Now assume z equal to 10 meter per second square and ignore air resistance. Okay. So basically we always ignore the air resistance, but here z is given 10 meter per second square. If z is not given, we have to use z equal to 9.8. Okay. So now solve the problem number A. So we know maximum height formula is H max is equal to Vi sine theta square divided by 2g, and here the given information: initial velocity is Vi equal to 200 meter per second, and angle is equal to 30 degree. So H max is equal to 200, which is the Vi sine 30. This is the angle. So sine 30 square. 200 sine 30 square divided by 2 into their acceleration is 10, mainly given below 10. Then maximum height is 500 meters. So this is the maximum height. Then in case of final velocity, is velocity after 16 second. Okay, so at t equal to 16 second velocity, we have to calculate the velocity. So since this is a two-dimensional motion, then the velocity has two components. So v equal to vxi plus vyj. So x component and y component. Now vx is equal to vi cos theta, then vx equal to 200 cos 30. So vx equal to 173.21. So this is the x component. And along the y direction, vy is equal to vi sine theta minus gt. So vy equal to 200 sine 30 minus 10 into 16. So it's vy is equal to minus 60. Okay, so it's negative mainly. So final velocity is v is equal to 173.21 I minus 60j, and the unit of the velocity is meter per second. Okay, and from this information, so you can say y component is negative. So this object or this particle just pass the highest point. Okay. Now next problem. So figure shows you throw a ball just towards a wall at speed 25 meter per second and at angle theta not equal to 40 degree above the horizontal. The wall is distance d equal to 22 meter from the release point of the ball. Now for number A, how far above the release point does the ball hit the wall? And B and C, what are the horizontal and vertical components of its velocity as it hits the wall? Last one, when it hits, as it passed the highest point on the trajectory. So let's solve one by one. Now in a given value here, initial velocity is vi equal to 25 meter per second, angle theta equal to 40 degree, horizontal distance x equal to 22 meter, and acceleration due to gravity we consider, which is constant 9.8 meter per second square. Okay. Now first one, we need to calculate the height. So we know that height h is equal to vi sine theta into t minus half gt square. So here, if we put the values, we know vi and also theta and also g, but we don't know the time taken to just hit the wall. Okay, so we have to just calculate the time first. Okay, so here given value along the horizontal plane is x is 22 meters. So just we can take the help from that information. So for horizontal plane, and just know that x is equal to vi cos theta into t. So from this we calculate the time. Okay, so t equal to x divided by vi cos theta. So x is 22 divided by 25 cos 40 degrees. So t equal to 1.15 seconds. So this is the time from throw to the hitting the wall. Okay, then now h is equal to 25 sine 40 into 1.15 minus half into 9.8 into 1.15 square. Just put the values in this first equation. Okay, so here h equal to 12 meter. So the height is 12 meter. Now question number B and C. So we know this final velocity v is equal to vxi plus vyj. So at time equal to 1.15 second. Okay. So Vx is equal to Vi cos theta. Vx equal to 25 cos 40 degree. So Vx equal to 19.15. And Vy is equal to Vi sin theta minus Gt. So Vy equal to 25 sin theta minus 9.8 into 1.15. So Vy equal to 4.8. So this is the basic calculation. So final velocity is V equal to 19.15 I plus 48 or 4.8 j meter per second. So from this we can say the x component is 19.15 and the y component is 4.5. Okay. Oh, sorry, 4.8. There is a mistake. So this will be 4.8. Last one, since the sign of the y component of the final velocity is positive, so the ball has not passed the highest point of its trajectory. Okay. Thank you.